Hi everyone, this is Prakash, and we are going through the ML using Python. This is the module 2, and Jamie Pusava, who is our what do you call the instructor for this course. Uh, we have completed the previously the Python, learning Python so that you can be up to date. We also have given you some exercises. If you can do it, well and good. If not, just put your mail in the chat window so that I can send the details. Now we are starting on this second module. We had one session on Monday. This is second session, descriptive analytics, and we'll follow with another third one, which will most likely be the Jupyter Notebook work on the module 1 and 2. We will not start module 3 before Monday, that's the next Monday. But in the meantime, I will hand over to Jamie, who is our, what you call uh, the host, our co-host. Let me make him the co-host so that he can handle it. Yeah, make co-host. So I made him the co-host and he can take over from here. Thank you, Jamie. Welcome.
Thank you for the introduction, sir. And hello, everyone. My name is Jamit, and this will be the module 2, which is a descriptive analytics. In module 1, we discussed about an introduction to machine learning. What is machine learning? Then uh, went went through some of the common topics for machine learning and how we apply them, what are the uses for it. In the next part of that previous coverage of module, we also discussed basic Python as well, a very short and brief introduction to Python. In this module, which is descriptive analytics, we'll be discussing first on what is descriptive analytics and go through some of the concepts while discovering the topic. And also in the next session, we'll be discussing about the visualization, which will be the part of descriptive analytics as well. So the goal of this session is to understand the concept of descriptive analytics, learning to load structured data onto DataFrame and perform exploratory data analysis, learn data preparation activities such as filtering, grouping, ordering, and joining of datasets. If you are coming from someone who knows SQL, you might be familiar with such concepts. Same for DataFrame as well. DataFrame is nothing but a structured way of putting data like we have it in SQL. Then learning to handle data with missing values. So about data descriptive analytics. Descriptive analytics deals with collecting the data and understand the past data, which answers what has happened. So descriptive analytics sets the foundation for 3 types of analytics, which is diagnostic, determining why did this happen, predictive analytics, determining what might happen in the future, and prescriptive analytics, what should we do next. Right now, we'll be focusing more on descriptive analytics. So I'll take a very simple example. Let's say there is a gaming console company, and we want to see the sales of the company based on months and the sales figures that it has for the respective months. So when we plot the graph, we are able to see that there are the sales reflecting to corresponding to the months, and which month has the highest sales and why. So you can see that July, October, and December, these are the months that have higher sales values. and it can be obvious due to holiday season or festivals and stuff. So the sales go high for the consoles. So that is this is what descriptive analytics kind of captures what has happened in the past, and also sets the pillar for the understanding of diagnostic, predictive, and prescriptive analytics. Uh, Descriptive analytics is not limited to numbers, but also visualization, as you see the graph over here. So the visualization also helps us to understand it quickly. So the primary objective of descriptive analytics is comprehension of data using data summarization, basic statistical measures, and visualization. So uh, normally data, how we want it in a structured format or in a date in a structured data. And this is what a structured data looks like. This is an example for the customers, the first name, last name, number, and the country. So data scientists deal with structured data in most of their data analysis activities and are very familiar with the concept of a structured query language called SQL table. So you can see that this is how the normally SQL table looks like. Depends on how a person has made it. But this is an example of how the SQL table might look like for a customer's table. So SQL tables represent data in terms of rows and columns and make it convenient to explore and apply transformations as well. So as SQL has other operations that can be made on different columns.
Hello, Jamit, I have one question.
Yes.
Hello.
Yes.
Yeah, question is, so is it always that for descriptive analysis data has to be in normalized form or something like which is not having nubs? Is there any prerequisites where the data has to be in certain manner before we do descriptive analytics?
So data has to be in a representable form and in an understandable form. So we'll see in this session only that there can be data sets where we do not have the column names or header names, so that we will give it header names and then apply the transformation and operations regarding it. So it has to be in a presentable form so that we can understand it before using it for descriptive analytics.
Okay.
So SQL tables represent data in terms of rows and columns and make it convenient to explore and apply transformations. So in the very similar way, like SQL presents data in a table and we have rows and columns to represent it, we have in Python through pandas something called as data frames, which is an in-memory data structure similar to you can say SQL for using in Python. So a similar structure for presenting data is supported in Python through data frames, which can be imagined as an in-memory SQL table that is data in tabular format. Data frames are widely used and very popular in the world of R and are inherited into Python by Python pandas libraries. So one of the reasons that we use pandas instead of NumPy is because pandas has this functionality of data frames, which makes it easier for us to deal with the data. So data and ways to present and work with them. So what is data? So data are facts and statistics collected together for reference and analytics. And this is Google's definition to it. So there can be different ways to represent data as well. So it can be a tabular format or a table format, which we commonly see in SQL. Then comes the graph. Graphs are used to visualize relationships between data points. Then comes charts, such as bar charts, pie charts, are used to display data visually. Matrices are used to represent data in a grid-like format. Then comes Venn diagram for the comparison between two relatively simple data sets. Then bubble charts, which makes a graph attractive type to be used in statistics and business. Then comes a decision tree, radar charts, cycle diagram, concept maths, flow chart, fishbone diagram, and more. So there can be different ways to represent the data. We'll be, as we have seen, that we have introduced a bit of data frames. We have introduced ourselves to data frames. So we'll be using data frames, but first we'll be seeing why. So first of all, NumPy. NumPy is another library, and on top of which pandas has been written. So first, let's see a bit about NumPy. So NumPy is an essential tool for data scientists, engineers, and researchers working on numerical and scientific computing tasks in Python due to its efficiency, flexibility, extensive mathematical capabilities. Now, NumPy is short for numerical Python, and and it provides supports for arrays, which is similar to list data structure in Python, but NumPy is a library specifically used for wide use of numerical computations. So that is the reason that NumPy is faster compared to list of traditional Python. So some key features about NumPy arrays. NumPy's array primary data structure is the AND array or n-dimensional array. These arrays are similar to Python list, but are more efficient for numerical operations because they allow you to perform element-wise operations and take advantage of low-level optimizations. Efficiency. NumPy is implemented in C and Fortran, make it highly efficient for numerical computations. It also provides tools to interface with libraries written in these languages. Then comes mathematical functions. NumPy includes a wide range of mathematical functions for performing operations on arrays such as addition, subtraction, multiplication, division, and more advanced operations like matrix multiplication as well. And also additionally having Fourier transforms and linear algebra operations. So apart from the simple arithmetic operations, we also have the complex ones or the more advanced ones. Then NumPy provides functions for generating random numbers and random data, which is useful for tasks like simulations and statistical analysis. So what we mean by simulations in this case is that sometimes a data set can have limited values and we want to simulate their values or have a random data around a lower bound and an upper bound and within that, or across a mean, so that we can fill those missing values and have the data set completed just in order to be able to be used. Then comes NumPy random module, which provides a wide range of functions for generating random numbers from various distributions such as uniform, normal, and binomial. These are three different distributions that we'll be covering further. It allows for further sessions, by the way. So it allows for efficient and customizable random number generations, which is essential for stimulating data. Data simulation is needed to create a realistic data sets for testing, validating, and developing models when real data is unavailable, expensive, or impractical to obtain. Then comes integration with other libraries. NumPy is often used in conjunction with libraries like SciPy for scientific computing, Matplotlib for data visualization, and Pandas for data manipulation and analysis. So, as you have seen that in the very first slide, the graph that we have used, the we had the numbers and we plotted a graph using those numbers. So that is how, in conjunction with of NumPy, we can use different libraries as well. So Pandas, SciPy, NumPy, Matplotlib, Seaborn, these are different libraries that we are going to be using for for the further sessions and for data visualization or data manipulation techniques. So NumPy versus Pandas. So as briefly mentioned before also, but we'll go through it again. Tabular data, NumPy doesn't have an inbuilt support for handling tabular data with labeled axes. So while you can use a structured array to store heterogeneous data, it lacks the more advanced data manipulation capabilities. So like we have the rows and columns, these are the functionalities that are added in Pandas, which is written over NumPy. Then comes missing data. So NumPy doesn't provide tools for handling missing or any values in arrays. This is a significant gap for data analysis tasks, as a lot of time data sets are not perfect. They can come with missing values or nan values or not a number values. So in these things, we need to handle the missing data that are that is present in the data set. So while NumPy doesn't have an inbuilt support for missing values, you can use special methods like np.nan, nan for not a number, to represent missing data in arrays. So even though there are workarounds within NumPy, if you only want to use NumPy or something, but NumPy has its limitations, and using a different library does help in conjunction with NumPy. Then comes data alignment and indexing. NumPy arrays don't come with features for aligning data based on indices or labels, which can be crucial for complex data operations. While NumPy doesn't provide built-in features for aligning data based on indices or labels, you can use advanced indexing techniques like Boolean indexing, fancy indexing, and advanced slicing to manipulate and align data in arrays. As I said, there are workarounds to handle the limitations of NumPy, but when we want a smooth work to begin with, we would like to use another library which has the functionality of NumPy, or which uses the functionality of NumPy on top of their own. So that is the reason that we use Pandas. So,
one question. So, please move back to the previous slide. Yeah, so I couldn't get this like indices and labels. So how we define them? So is there any pictorial representation that where this problem comes?
so, uh, there can be data sets that can start directly with their columns. It can be, let's say, about different features regarding a car. Okay, so the rather than having an index or labels connected to it, it can directly start telling us about the cars or the columns that the dataset contains for cars, like how much cubic capacity it has, and other engine specifications and stuff. So in these times, we can use different indexing, but uh, when we use pandas, it has its own dedicated features to use the indices and stuff. So in that place, NumPy kind of falls short to it.
Okay, a bit confusing, but if possible, some pictorial representation to understand.
I'll try
Means I'm
to
not. Uh,
I'll try to have a pictorial representation to it.
yeah.
Yeah. So continuing with pandas, tools for reading and writing data between in-memory data structures and different formats. So CSV files are very common, but it does support other files as well, for like CSVs for comma separated values. The And then we have the reading the Excel type sheets or SQL tables, and the fast HDF5 format as well. Then the intelligent data alignment and data integrated handling of missing data, gaining automatic label-based alignment in computations, and easily manipulate messy data into an orderly form. Flexible reshaping and pivoting of data sets. So this refers to creating a different data frame altogether, or creating a different data frame from an existing data frame within the data set. So pandas and working with them. we we import pandas and then give it an alias of PD as to use further in the whole program. So we'll be using a data set. So you can use a data. First, we have to create a data frame, which where we will be able to read that data set from. So our data frame would be IPL auction DF, IPL auction data frame, and then we will make it read the dataset file that we have it stored in. So for that, we go for ed.readcsv, as this is a CSV file, and then give the name of the dataset. Now we can directly give the name of the dataset if the program that we are running in is in the same folder as the dataset file is in. So and at that time we can directly run it by giving the name, but if not, we can give it using the address as shown below in the comment. So like read CSV, which is present in Panda, we also have read JSON for a JSON format file, then FWF, which is a fixed width format, then Excel files, and a table for database tables. So whichever data set you are trying to read, you can read it through these. So regarding the read CSV, you can try this command and have a very detailed explanation regarding all the details. Though this is just a small screenshot, but you can see that it contains a lots and lots of details. As you can see that there is also a drag down option to it. So it contains a lot of details, and you can try to explore some of the things that intrigues you. So for this session, we are going to use a dataset for IPL, as we have uh, as this data reads, or this read CSV command reads. So this is an information regarding the dataset. It contains age, runs scored by a player, runs conceded by a player, and all the information necessary regarding that. Now, that just a second. Now, there is also so the uh, first is first column is age, or here in the descriptive way, we can say within data code there is age. So have a look at it, how the age has been created as a categorical manner, which means that this age row has three categories. So player from one age to certain age has belongs to category 1, then certain age to some other age belongs to category 2, and then category 3 for some certain older players. So these categories will also be used in further explanation for different concept as well. So let's say just like in Python, we have a type function over here as well. So if we type and give the data frame into it, it will tell us about the type of the frame it has. So we have it pandas, which is a core functionality to it. It belongs to pandas. It has a it belongs to a core functionality to pandas, and it's a data frame structure. When we print the data, when we simply want to print the data set, it will be printed like this, as you can see in the screenshot attached. But you can see that in row wise, after 5 values, we cannot see the values between, and then it kind of gives us a summary containing top 5 and the last 5 values of the data set. The same goes for columns as well. We have the first few columns, and then the missing columns are not there. But in the end, we can see beneath the data that there are 130 rows, which means that we have 130 entries or observations, and we have 26 total columns. So just in case, if you want to display the whole data set, you can use the pd.set option, and in this you can use a display.max columns and none as a other argument. The same goes for rows, so which will help you display the whole data set in the single cell. Just in case you want to get back to this setting, you can use the reset option and give the arguments display max columns and display max rows for both. Then using a print statement, you can see that when we give a print statement, it's not coming in as a data frame format, but rather a series pd.series data structure, which exists within pandas. So this series data structure displays the values like these. Now, if you want to simply see the top 5 or let's say a few records of the data frame that you have created, you can use a dot head and then give the number of records for it. You can use it till 60 and have the records printed that way. And then if we want to see which are the columns that the data set is consisting of, so we have a data frame name dot columns, and it will give us the list of all the columns that are existing in the data set. And if we want to uh, print it in a vertical manner, you can print it using the list and have it within the list structure as well. Then if we want to change the rows to column and column to rows, we have used it on head function that we have used, head method that we have used. So so now the rows are columns and columns are rows, and just in case if certain data sets need certain uses to it, then we can use that using the transpose method. Now, if we simply want to know about the size of the data set, as we discussed about it here, that we have 130 entries and 26 columns. If you want to know that, we can use it with giving a dot shape function to it. So it will simply it will simply give us the values to what the data set contains of. Then comes information regarding the data set. We can use .info for .info with the parentheses, and we can get the information regarding what each and every columns are with their indices, as well as the data type, the kind of entries that these data types contain. And you can see all of them have 130 values, which also means that we do not have any missing values or something. And in the end, we have the data total, the kind of data types the whole data set contains. So D types contain float, integer, and object, and all of them, which contains what? How many of them are float type, integer type, and object type. And then the memory it takes to use the data set. The object types are basically any other than integer in a float. Then comes slicing and indexing of data frame. Just like we have string methods to access a portion of a string in Python, we can do that for our records as well, or within the data sets entries as well. So for viewing the first 5 entries, we can simply use the 0 separated by column and the ending entry. And the reverse indexing works as well. If we use the -5 for as a starting argument, then we get the last 5 entries of the data set. Then using slicing or selecting the column names from the data set, from the data frame, sorry, from the data frame. So we are using the player column name called player name, and then using the first 5 entries to be displayed. We can also use multiple column names and uh, make it display, combining with 2 columns and separated by comma. For selecting specific records, for the so this is a so there's a syntax to it. So we can give the data frame name, then use the ilog function, and within ilog function it takes the following arguments, which are start row index. So first it will take the row indices, and then it will take the column indices separated. And the row indices and the row indices will be separated by colon for start and end. The same goes for uh, column indices for start and end, separated by colon, and both of them separated by comma. So this is a common syntax. So as we saw, so we wanted to present from index 4 to 9, 4 to 8 actually. 9 will not be included. And then for columns, we wanted to go counting from index wise, from index 1 to index 4 or index 3. So this is the code that was used for plotting the introductory graph that we used. We have not yet covered anything regarding the matplotlib library that we have used here in order to plot the graph. But just in case if you want to recreate it, this is the code for it. We'll cover the matplotlib graph, matplotlib as a library when we discuss further concepts. And this, so this is the graph. So this is the graph that we have created for learning about the descriptive analytics and how it is used for representation and about the past data, and where they are showing a certain kind of rise in the sales according to month. So we started with pandas. We imported pandas as PD, and then read the CSV file for a data frame. So the data frame contains the read CSV file. Now once the data frame is on, we can use it for our different purposes of applying different operations and stuff. So for displaying the whole data set, you can use a set options in a single cell. You can use set options, display max columns, and give the argument in the second argument. The same goes for rows and columns both. And for reset, you can run this command in different cell in order to reset that and have it in a summary way. So you can see that this whole it contains the whole data set of 130 values. Then I talked about the pd.series way, which is another data structure of pandas, which displays uh, results in this manner. It also has the whole structure. Now, summarizing the data set. Uh, so for accessing only the columns of the data frame that we have used, we can use dot columns. If we want to have it within the list, we can use it within the list and have it displayed over here in a more readable manner. Now head options for displaying certain parts of the data set. And as written, you can use it till 60. This is same because I have not reset the options. Now, using transpose in order to switch the places of rows and columns to each other. Then comes the size of the data set. So these are the rows and these are the columns. And
In the above one where we have the head 5, okay, what exactly that does, head 5?
so are you talking about head or head transpose both?
Head 5. So when you give 5,
So
so
5 is the number of records. So it will take these records.
okay, okay.
Yeah. So that's what I said over here. So this is the normal way that we are doing. This was the transposed version of it. So when we use head 5, so 5 are the number of records that it displays. So from 0 to 4, it displays this, and you can keep on doing it till 60. After 60, it will show the same result again and again. So you cannot use head for displaying the whole data set.
Okay, so how to, so if I have more
It's kind of
data,
a summary for the data set in a
okay,
way.
okay, so how then it will cater to if I have millions of records or something where I want to view and do the summarization on the basis of search, and so is there any limitation to handling of data frame in pandas where I say that I have 1 lakh records? Okay, so
So we are using data sets which are in a certain numbers, or the entries are in certain numbers. As you can see that we are only using a data set which contains of only 129, or sorry, 130 values. So in small representation, it will be easy for us to use these methods, but for large, it would be a different thing. Like a billion or million values, it will be different thing.
when we have million records, so
Yes.
will this work or not? So will, or do I need to have a
It, it
different approach
It will work,
towards?
but when you have a million records, you don't know whether it's a continuous records, like it's updating with time or not, or is it a static value from taken from one date to another. So it depends.
No, my question is a bit different. So what I meant to say is, when we are dealing with so many records, even
Yes.
if it is the display will be huge. So
Yeah.
what is the way to view that? So as a export, can I export the data of this particular operation to a CSV and then get that as a download? Is it possible?
Yeah, you can use millions of records for your own operations and get the particular insight that you are going for. I hope that's it.
Okay.
Am I able to answer it or?
Okay, fine.
So, to transpose so the transpose is used in order to convert the rows to columns and columns to rows. And we have, as you can see from serial number to the sold price, we have transposed the columns to rows, and we have our entries in a column format. Then comes the shape of regarding what are the rows, number of rows, and the number of columns that are present. Then comes the information regarding the data set that we are using. So we have the type of type, which is a data frame for us. Then comes the entries, which is from 0 to 129. Then comes the different information regarding which column contains which values. So you can see int, object, and float. And you can see how many columns contain these kind of values, and based on the data type and the memory usage it takes in order to use the data. Then we used slicing operations just like in string. So 0, 5 in order to display a top 5 values of the data frame that we have been using, and -5 to use a data frame for the last 5 values. Then comes the player displaying the records based on the column that we are providing. So here we have provided player name and then the values that we want to display. We can do it in combination with both of them, 2 different columns as well. And using the iloc method, we can use to display specific entries based on the indices. So we are using 4 to 9, so it will display 4 to 8, and 1 to 4, so it will display 1 to 3 index for columns, and 4 to 8 for rows. Now, as we have seen some of the simple methods that we use on data sets in order to get simple things done, like how to view certain data and stuff, or slice the data. Now we'll try to gain some insights from the data that we are using here. So first we'll be using the value counts, which counts the occurrences of unique values that are in a series or a column. So let's say we want to see how many players played in IPL, and from are from which countries. So if we use countries and use value counts, so it will tell us the unique the unique value, counting the unique value, how many players have played of belonging to each country. So you can see starting from India, Australia, South Africa till Zimbabwe, we have their corresponding numbers. So the value counts has different arguments, which is first is for normalize, then sort, ascending, bins, and drop any. Now, starting with sort, sort actually uh, sorts your it it orders your value in from lowest to highest if given. Sorry, it sorts your value from highest to lowest if given true. So you can see for our just a second. Then comes ascending for sorting it through lowest from highest. Then bins for creating different groups, and drop NA for dropping the NA values. Now we'll be discussing these arguments as we discuss certain function, certain concepts, uh, and while using the value counts. So here we want to see how many players contribute in a percentage wise manner. So how many players consist of all the players in a percentage representation. So we are using normalize equals to true, and using and converting it into a percentage for its representation. So India has the highest percentage for 40%. Then comes Australia, SAS, Sri Lanka, and so on.
What does normalize function actually is doing is the calculating the total portion it has out of the total data set for the.
Yes, it's normalizing its value basically, and then we are multiplying it by 100 uh, for its percentage calculation.
So if there is a null value, so is it going to normalize first? What is the
So,
order of precedence? Like
so,
normalize first, sort first, or drop NA? So what order
so,
it takes?
so as I mentioned over here, we will have to use a drop NA first in order to drop those values, so it doesn't come into count, and then use it.
Okay, so so these arguments can be changed as per the data set. So
Yes,
drop NA
yes,
first.
yes. According to use, you can change it however you want to present it. So if you sort equals to false or default false or true, and depending on that you can get the value.
So if I don't give ascending, by default it will take ascending because I have given sort, right?
Yeah, actually sort and ascending both are used in combination, so that it it gives you a very flexible way to present the data that you are trying to get. So
Okay.
what
Okay. Okay.
yeah. So after using after displaying the normalize function,
So, so
yeah.
does it normalize with like upper upper limit or lower? So upper bound or lower bound, or so normalize is up to 1, 2, 3, 4, 5 decimal places it has normalized. So by default, it takes 5 decimals, or we have options to set these arguments, or set these arguments before these execute the uh, for a particular data. Suppose I have one panda, I'm using PD. Okay,
Yeah.
so I want to follow certain argument setup for one panda set. For other, I want to follow different. So like class function, you has to you define that class inherit and all those things. So how we do that? So here I want to do normalization first. I want to I rather than doing or setting these variables again and again, I want to use certain order for one set data set and certain order for other type of data set.
Yeah. So in that case, you can also create a different column, or you can create a different date. If it's a data set, then you can create a different data frame altogether in a way. So you can add, let's say uh, you want a sold price based on the age group. So you can create a separate column and have that calculation. So in the same way, if you want to normalize one column, you can create a different column altogether for it, and then use that column for whatever use you want to. So similar to value counts for a single column, we can use cross tabulation for multiple columns. So we are using value counts for a single thing. We just wanted to see how many players belong to which countries. If you want to do it for multiple columns, then we can use pd.crosstab and use the columns that we want to go for. So first is for age, and then for the playing role. So depending on the role and the age, it gave us the values that from which age which player belongs to which role.
Sorry, I'm not able to get this. Can you please detail again how this works?
This value or value
No,
count or
no,
cross tab.
how cross step, cross step.
Cross tab. So for value counts, we did it for a single column, which was for country, and gave us the unique value of how many players are there. It basically counted the number of players which belong to one single country and gave us the information regarding that, right?
Okay.
So for, but it was a single, it took a single column, which is country.
Mhm.
But what if we want to do it for a multiple columns? So we have age. So remember that age was divided into three categories for the data set that we are using, which represents three categories from one age to another. Let's say from 19 to 25, it's one, then 25 to 35, it's two, and 35 plus are age category three. So for this, we wanted to use that which category, which players belong to according to their playing role. So we have an all-rounder for age 1, or let's say the category 1. So we have 4 all-rounders for age category 2, we have 25, and then category 3, we have 6. And so it goes for batsman, bowler, and wicket keeper.
Okay, so how is cat a keyword over here? Cat one, two, cat.
Category 1, category 2, and category 3.
So
No,
is it it's a keyword?
no, just a second. So, so remember this, this is the description to it, right? To the data set that we are using right now. So the age, the very first age, this was used as a categorical value rather than uh, uh, directly a number, because a lot of players can um, be of a different age, and there is it doesn't make sense to create a different category for a same age. So rather than that, we use a whole limit from till let's say less than 25 for one and stuff. So this is what it represents for category.
So, but how we created this? So that is my question. So how
The
we
the data
how
set is already created and we are using the data set.
okay? Can you just show that Excel where the data set is already created?
Just a second.
It will be easy to link the pieces, the function. Yeah.
So this is what you.
So age is there, okay.
Yes.
Age is there, playing role is there, okay. Okay, age 1 2 1 2. So it has so how this age 2 1 2 1 2 has been categorized. So this data set has been so this is the source, data source, right?
Yes.
Age 2 2. So how we have, so if I go to cat 1 cat 2 cat 3, was that as part of syntax or statement, or is it a keyword cat 1 cat 2 cat
No,
3?
no, cat. That's a doc string that I have used, the cat one and cat two. Just a second.
So yeah, so that I was not able to get how that actually identified or created.
So this is simply. Oh no. This is simply the category that the age has been divided. So
Hmm.
this is nothing but the doc string, which simply describes what it does. So uh, I've just used the doc string to uh, describe what the age category means. That's it.
Okay, so okay, this doc string I have not used. Okay, I didn't. I'm not aware. Okay, fine.
So what you are asking is a category, a cat one, cat two, cat three are not variables or something. These are
Yes.
just descriptions, and it's a sentence that I have used. So just in case if anyone is like, it's not easy to understand the age thing, that how it has been used in the data set. So that is the reason, for reference, I have used this category 1, category 2, category 3, so they can refer it to which one belongs to which category. So because so for category 1, the players that are smaller than age of 25, we have 4 all-rounders, 5 batsmen, 7
Okay.
bowlers, and 0.
Okay. Okay. This is just a comment, so it has
Yeah,
no.
yeah, it's a command. So it's a
It's
document. Yeah.
okay. I thought it means because you have mentioned age, and so I thought it is part of some syntax or
No, no,
method where it is consumed. Okay, fine.
no. So doc strings are always used whenever you, let's say you are defining a function and you want to describe something regarding it, of how it works. So at that time you can use a doc string to tell other people who might be referring to your code, to tell them exactly how the function works. So you can also see it as a multi-line comment.
Okay, can you just go and show the execution of this piece on?
Just a second, I will be going through the concept and then go to
Okay,
it. Yeah.
okay,
So sorting data frame by column values. So we have a sort values which takes the column names, then based on which the records needs to be sorted. By default, the sorting is done in ascending order. So what we are using sort values for is we are taking two columns. You can see that IPL auction DF, it contains two columns, player name and sold price. Now we are using the sort value to sort the values according to the sold price. So by default, it's in ascending order. And when we print the first five records, you can see that for it sorts in the sold price lower to higher. But if you want to use highest to lowest or in descending order, we can use the sort value price, sort values according to the sold price, and then ascending equals to false. And when we print the first five records, you can see that we get the highest players to and the highest five players for the IPL.
okay.
Now comes creating new features or creating new columns with the existing columns. So let's say we want to see which are the players which are carrying a premium tag. Now what we mean by premium tag is just the difference between the sold price and the base price. So that in the dataset there is a base price that we have and the selling price of that player and what is the premium that these players contain. So first we use the DF or the data frame's name, then give it within the square brackets, we give it a column name, and then use the columns in order to uh, have a simple arithmetic operation of subtraction for the sold price and the base price. And when we present that uh, those columns along with the player name, uh, we get the we get this screenshot or the result that you can see.
Okay, one basic question. Okay,
Yes.
so when I have two like these two statements of data frame, okay. So first one is processing the data. Does it update that data frame itself, or it retains the data frame only the output? So data frame value retains in the same. So it's like if my data frame has value A, and in first statement I do
So
yeah.
so just in case you are asking that it modifies the original data frame or not, right?
Yes, yes.
Yes. So it's a very good question. But so because in this very session, I'll be discussing about it. So I will just shortly say it that there is a if you want to create a copy of the modification, you can do that as well. If you want to directly change the original data set to reflect the changes, and you can do that as well. And there is an argument called in place which comes, and we'll be discussing in further only.
Oh, okay. So, but
Yeah.
in this case, is it actually replacing the value? It means here
We
I'm assuming.
we are creating a new a column called premium. So that premium will contain these values. The others are simply we are displaying. So player name, base price, sold price. These are the names as it is. The premium will be containing and the the whatever operation we did, that will be containing the value to it. So premium will be added to the original data frame.
It's like a appending, okay, but column appending. Yeah, good.
Yeah.
Thank you.
So for sorting the values from highest to lowest for the premium in a premium wise, so we created a premium category and then displayed the first five, and in ascending order it gave us the values. But if we want to see the highest player who got it, so we made the ascending value equals to false, and then it will give us the first five players who have the who had the highest premium. So you can see that player number 50 or index number 50, Virat Kohli, has the highest premium, and so on for other players as well. Then comes grouping and aggregating. So grouping and aggregating is basically we can group different columns to, to create new columns and stuff. So sometimes we need grouping and apply aggregated operation functions. So example, average stays for different quarters, or average runs scored, or goals scored. So so for that, for our case, we'll be using sold average sold price according to age group. So which player belong to which age group and their respective average sold price for it. So we'll be using the group by function to group the age and the sold price for it, and calculate the mean on it. And when we calculate the mean on it, we get the average mean or the average sold price according to the age group. So you can see that category 1 has the highest average, then comes to category 3, and then comes category 2. So the so this is also the output in pandas.series data structure, and we can create a data frame for it also using reset.index. So for the same code we have used, after mean we can use a dot reset index, which will use the same index which was in the original data frame, or was originally in the data frame, and it will give us the data frame as well, or the data frame representation as well. For using the multiple columns, sold price by age and
So
the role of
reset index is how much?
sorry,
Means reset index. Sorry, I couldn't get this. So how it does that reset index? Because mean is once calculated.
yes.
So so is it resetting the data frame already
No,
where the
it's
mean has been?
so instead of creating a new data frame and have a new index to it, we'll be using the old index. So we have created a data frame, and then let's say we created another data frame using the previous one. So it a reset index makes use uh, of the original data frame that we have used and not create the new ones, so that it's easy for us to keep on looking at the original data frame in order to use it.
Okay, so if now if I have created another data frame sold price by age and there are IPL auction data frame. Now there are two frames. So are they keep on linked? If I change anything on the data frame of IPL auction, will it automatically update the from which it has been sourced, or it will both will be treated as a separate variable? So how here, because we have linked, both are pointing to the same data set, correct? Now if I
Yes.
change the suppose mean value of one particular iteration age group. Okay, so mean, instead of mean I change a mean of category 2, age 2, index 2. Okay, will it alter the sold price by age also?
We are only calculating the sold price by age, so we are not altering anything to the original database or data set, but
Okay,
we are actually calculating the from the original data set and saving the results in the sold price by age.
okay, okay, purely assignment. Okay, fine.
Yeah. So next is combining columns. So combining columns from multiple data frames into one single data frame. Data frames need to have a common column as well. So if you want to combine two columns, we can do that, but those two columns should have a common column to combine as well. If if you are aware of SQL, then you can use the so for merging this sorry for merging this combining columns, we will be using pandas.merge method, and with it takes a lot of different arguments, and right now we will not be using every one of them, but we'll be discussing only a few that we have to use. But just in case, if you want to picture it, the what the inner left right join and full outer join means, you can see it in the representation, as we are as the representation is from SQL's point of view. So it says table, so, but in this you can think of it as columns. So the inner join means something that is common to both column 1 and column 2. The left join means something which is common to column 1 and 2, but or something which is common to column 1 and only 2. Then the same goes for right, and the full outer join means combining both of them. So we are creating a sold price comparison, a DF, that we have used. So sold price comparison TF will be consisting of a column which we have used for age and role both, and merging the column with the sold price by age. On what we'll be merging? We'll be merging on the column which is common to both sold price by age role and sold price by age. So we'll be merging on age column, and how we'll be merging? We'll be merging on the outer join. So we'll be merging all of them. So when we merge both of them, this is the output that we get, and you can see that by something that is common in both the tables. So sold price was common, so it will uh, it will rename on its own. So we have sold price X and sold price Y. So what does sold price X represent? It represents the sold price from the left table that we have joined or mentioned, to the sold price Y, which represents the table on the right table, or what we have mentioned in the right.
Can you show me the left table and right table? Means the data set, which one we have for?
So you can see the top line, right? Sold price comparison.
Okay.
So that's what the left and right can be represented over here in this code. So
No, no.
sold price.
If I'm trying to link mathematically, like I have two tables, okay, SQL. So which one is table one and which one is table two? So I'm trying to link those. So do we have the data set for table one and table two? This is combined, right? This is the
Yes.
result. This is the result. So this
Yes.
is not, no, I'm talking before the result. What was table 1 and what was table 2?
So, okay, you want this kind of representation for table one and table two.
Yeah, yeah.
Okay. I don't have it in the slide, but when right now I don't have it in the slides, but I'll try to cover it later. But
Okay.
for your doubt for table one and table two, which is the reference to this over here, if you can see in the command line that the first one, age by role, reflects to the sold price by age role reflects to the left table, and sold price by age, which is given as an argument, is reflecting to the right table.
Okay. Okay. A bit tough. Okay. Actually, I want to see the example. Theoretically, it's getting a bit difficult to understand how it's
Uh,
operating.
okay, I will. I'll see if I'm able to create it. I will create it. Okay. So now I'm renaming the columns as we were discussing about the sold price X and sold price Y, which were renamed automatically, and what they refer to are the left table and the right table for X and Y respectively. We want to rename these tables. So sold price comparison dot rename. We give the columns and the column names that are existing right now and the name that we want to change it to, separated by the colon. And then if we further want other columns to be named, to change the name, we can simply do the same using separated by a comma. So we are changing the sold price X to sold price age by age role, and sold price Y to age price, sold price age, and in place equals to true. So this was something that I was referring, that the doubt was also asked, as in place is the argument that you take when for in place equals to true, it will reflect it back to the original data frame that we have been using. If in place is equals to false, it will create a duplicate data frame where the where the changes will occur, but it will not reflect it in the original data frame. So in place equals to false is the default. The method will return a new data frame with the modifications, leaving the original data frame unchanged. So we are using in place equals to true so that the modifications happen in the original data frame and returns none. So then for the created data frame, sold price comparison for head and displaying the first 5 records, we get this output. So you can see that now the column name has been changed from X and Y to sold price, age, role, and age. So we would like to find a different. We would like to apply different operations on multiple columns too. So we would like to find whether player carries a premium if they belong to a specific age and playing role category. So so here in this formula, premium is called will be called change for the formula that has been used. So the formula states average sold price for all the players in age and playing role category minus the average sold price for all the players in the age category divided by all of them in the age category. So for implementing this formula in the in Python, we can use a sold price comparison and have a column called change. And here we will be using the sold price comparison dot apply for applying a function, and we will be using the lambda function, which will be taking the sold price age role minus sold price age and simply representing the formula that we have been using. So sold price age role minus sold price by age dividing by the sold price age. And here x is equals to 1. So which will be an additional argument that we will give. So x is, when it is given as equals to 1, it applies the function that we are discussing about to rows. When x is equals to 0, it applies it in a column wise. So this is the output that we get for the change uh, that we made a calculation on, and you can see the different values it shows. For the players and the change it possess. Now we want to make a data frame to check based on conditions. So we want to see that which player hit the most sixes, or let's say there is a column, and we want to see that for this particular column, what would be the value greater than a certain value. So we'll be using our original IPL auction DF, and within that we'll be taking the the column name called sixers, the players who have hit sixes more than 80 times, and then in the end we'll be displaying the player name as well as the number of sixes through sixers column. So we have the first 5 players who have hit most sixes. Actually, these are the only players who have hit sixes more than 80 times. So we have 5 players who have hit sixes more than 80 times. Now comes now comes dropping a column. What if we have a data set and we are not using a column? So you can see that if we go back to the first IPL auction df dot columns, which list all the columns that are present in the data set, you can see that we are not using serial number, which is the first column. So for that, to remove a column or a row, we can use a drop method on the data frame. It takes a parameter axis to specify if a column or a row needs to be removed. So for that, to drop a column, which we are trying to do, pass the column name and axis as axis value equals to 1. So we are using it on the original data frame as well. So we are using the drop function, giving the serial name as the column that needs to be removed, and we are using in place equals to true so that it reflects the original data frame, and also axis equals to 1 for denoting that we are trying to drop a column. And after that, when we print the columns, you can see that serial number has been removed. So regarding the value counts and cross tabulations, we wanted to see how many countries have participated, or how many players have participated from each countries, and we used value counts as the method on it. And you can and when we ran this, we got the output of these countries and their respective players participating. When we wanted to calculate the percentage contribution from each players for the same values, so India, Australia, South Africa, Sri Lanka, and so on contributed their percentage share. Then comes the cross-tab method in order to use multiple columns. So here we have used age and playing role, both of them, in order to count for each one of them. So according to the age that we have as a category of 1, 2, 3, we got these number of players from all-rounder to wicketkeeper. Then sorting the values in the data frame. So we are taking two columns, player name and sold price, and sorting the values according to the sold price and displaying the first 5 records. So these are the records according to the sold price, but it is in ascending order. If you want to do it from highest to lowest, we can simply give the argument ascending equals to false, and it will display from highest to lowest. Then we created a new column called premium, which for finding which player which player carries a premium price with them. So there was a base price for the players and the sold price. So we simply deducted the base price from the sold price, and then displayed the result with these columns. So in order to get more insight regarding the name also, we displayed the first 5 records for getting the descending value, as ascending is by default. We gave the argument ascending equals to false for this. Then we discussed about the group by function to calculate or have certain operations on it. So we took age and performed the operation on the sold price for mean to get which age category contains an average, what amount of average price. So these are the mean values for the age category. According to the sold price. Then we used sold price by age of because it was in a series structure. If we want to convert it into a data frame, we can use a reset index in order to get the price in a data frame format. Then we created another column for sold price by age role. Gave, group used age and playing role, and also the sold price for calculating its mean. So we got this value, this output, which contained the age category, as well as the playing role that each and every player contains, according to and their respective sold price as well. Then comes joining data frames, taking multiple DF and joining them into one. We used a kind of these are some of the these are all the arguments that it takes, but we'll be using only some of them. So we use a sold price comparison, sold price by age, and then use the merge method on age, which is a common column to both sold price by age and age role both, and the kind of join that we want to create, or the kind of merge that we want to create. So it was an outer merge which consists of all the layers of both the data frames. So when we create this sold price comparison, and sold price being the common one for both of them, it creates a separate column and names it automatically by underscore x and underscore y. So for changing these values, we used a rename function on what columns, and then used sold price x, the column name that is existing right now, and the column name that we want to change it, and separate it by comma for further changes if we have it. So, and the same, the name we have right now and the name we want to change it to, and in place equals to true for it to reflect on the original data frame. Then sold price and then displaying the sold price comparison and its first 5 records. Then comes so we also made a sold price comparison for applying this formula in Python. So we used it using apply, then created a lambda function within it with the variable rec, and which accesses the value of sold price by age minus sold price age, sold price age and role both, and sold price age divided by the whole sold price age. Access equals to 2, access equals to 1 for row, and this is the data frame that we get for it. Then we then we wanted to see whether players uh, which players had hit the most amount of sixes, and we kept so basically creating a data frame based on a condition. So we use the data frame that we are using and the column that we want to access of that data frame and the condition. So sixes, for number of sixes greater than 80, and then we want to display the player name and the sixes that the player has hit. So you can see the number of players who has hit sixes greater than 80. Then we talked about removing a column. So we used a serial number to remove we removed the column serial number using drop method. And after using after dropping the method, after dropping the column, you can see that we do not have the serial number as our column. Next, next is how to find missing values and removing the missing values. So for this, we'll be using a different data set which contains information regarding cars or the specifications of a car. So the dataset that we are using is called autos.mpg.data, and and the information it contains is the miles per gallon, or its average, then the number of cylinders, and so on. It has a total 9 columns. Now, this data set is a space-separated value. So when we use it to read the data using pandas, so we have read CSV, and then uh, along with that, we'll be giving a separator argument, which uh, which denotes the /s denotes a single space. The plus denotes that there can be additional spaces and should be included as well. So separator as the argument and its value, and then header. Now in this data set, we do not have a header or the headings for the data set. So you can see that when we run this, we do not have the name of the columns. So that is why we are using header equals to none. So when we print this, print the first 5 entries for the data set, you can see how the data set looks in its raw form. So, after that, we will be naming the columns. So we use autos.columns in order to name the columns and give the respective names to the columns that we have for the data set. So so we gave the miles per gallon, cylinders, displacement, and so on till the name of the model. And when we print the head, autos.head again, like here, we have the respective names for the columns as well. The information regarding the data set you can see that just the like the IPL data set, we use the info over here. And here you can see that the horsepower, which should be a float 64 type, is displaying an object data type. Now, and this can happen because it is containing some values that are not numbers or a float type. So to convert the horsepower columns into numeric values, we'll be using pandas dot numeric method, which takes parameters as errors, which specifies how to deal with non-numeric values. So the it takes a raise, coarse, and ignore as the parameter errors. A raise for the invalid parsing will create an exception. Coarse for invalid parsing will be set as a nan, and ignore if invalid parsing will return the input. Now, because we are dealing with nan values, the autos horsepower, the column that we are working with, will be converting it to dot numeric and giving it the errors parameter as coarse, and will be displaying the will displaying the change. So when we apply the change, you can see that the horsepower, which was showing us object first, is now showing float 64.
A bit confused. So can you execute this, or what exactly it has done?
Regarding what, are you confused?
The course, the second option. So first is it will raise the error exception.
Yeah.
Now, if we then if course, then ignore raise course. Default is raise. Okay, is it automatically identifies these three ignore raise course?
So by default, it's a raise, but because we are dealing with a nan value, we will be going for coarse as a not a number values.
Okay, so in errors equal to course, we are setting it as to make it nan, make it course, right? So that is what we are trying to
Yeah,
do.
yeah.
Okay, if ignore, then invalid parsing. What was the third one? Sorry, I couldn't get the third one.
Ignore for invalid passing will return the input.
So, okay, return the input as is. There won't be
Yeah,
any
yeah,
action. Okay.
yeah. So you can see that now we have numeric values, as well as one of the changes you can see that we have 392 for horsepower, which showed that it had nan values, and we corrected it. So for that, we'll so to check the null or the missing values in particular column, we use is null method on that particular column. So because we are working with horsepower, we'll be using is null on that. That so Just a
Hello,
second. Yeah.
hello. Lost you for last 30 seconds, so I don't know whether.
No, no, no. I was not speaking actually.
Okay.
Yeah.
Yeah, I also thought we lost him.
No, no. No, no.
Yeah, Jamit, if you need to drink water or something, take no break. But
Yeah.
tell us that you are doing that so that we know that we'll have to wait. Yeah, continue.
Yeah. So, uh, so we use the is null method in order to check for the null and the missing values. So for this, we will be using the autos dot horsepower, and we get the total. We have total six records where there are null values or the missing values. So it will display those values, and when we uh, in order to deal with those values, we drop those rows. So using drop NA method, rows of data frame can be dropped. So drop NA method removes all the rows with nan values where horsepower is the only column to contain missing values. Because we are dealing with the nan values within the horsepower column, it will remove all the rows when we use the drop NA method. So when we run this again and check whether the horsepower contains is null, then you can see that it does not display any rows because those have been removed and are dealt with. So summarizing, I'll be going through the code. So handling missing values, we started with a different data set, which was a space separated data set. We went for the space value as well as additional values for which signifies with the sign plus. And header equals to none as this data set does not contain column values. So that is why it will be representing the numbers like these, like similar to indices for columns. After that, we named the columns by using autos.columns and gave the respective names. And when we present the head, present the first five records using the head function, we get these values, as well as we can see that the names that we have changed for the columns have been reflected. Then regarding the information regarding of the data set, you can see that horsepower contains 398 values, whereas horsepower is something that should contain numerical value, like an int or a float, float to be specific. So, but it does not contain float, as well as it is showing objective data type. Sorry. So in order to deal with that, we are converting the horse to numeric values and errors equals to coarse. And as you remember, uh, coarse is used for dealing with nan values. So after going through these, when we use the autos.info again, we can see that the values are being created, the values have been converted into numeric type, and there are 392 values now. Now we check for whether there are missing or null values within horsepower or not, as we have seen the discrepancy in this record only. So we check the we check for horsepowers and missing values using is null, and we found 6 total records that were 6 total records that were containing those missing values. So we used the drop any method on horsepower, and after dropping the rows which contain the missing values, again we check for the null values. Now we do not have any record showing up like it was over here. So to summarize the descriptive analytics, first we started with the concept of descriptive analytics and how it acts as a pillar for other analytics like predictive analytics and stuff. Then we learned about load structured data into DataFrame and perform exploratory data analysis. Then comes the then we discussed about the data preparation activities by filtering, grouping, ordering, and joining of datasets. We use the IPL dataset for these values, and we used we used the selling price of the players and grouped it using the age and role, both of them. Then in the very end, we discussed about handling the dataset with the missing values. So this was all for descriptive analytics. In the next session, we will be discussing about the visualization of descriptive analytics. You can also go through some of the references that are presented here, except the last one. It refers to the future session.
While the plotting you will cover next time, right?
Yeah.
So I think you are at the end of the call, right? Any questions? And please drop your email so that we can send you all the slides and all. We want you to be participative. So rest assured, we will not be using it for any other purpose except to share with you all the information. So just drop your email on the chat and we will follow. So next week, as Jamie said, he will be covering visualization, and most of the data analytics require visualization. Even for that matter, even the ML and all, when we do some kind of a probability and all, we will be requiring a lot of what you call the distribution and graphs and plots and all that. So definitely we want to make sure that you learn that. And so it was great seeing all the extra effort, especially Saurabh and Nikhil, and I don't know the new person who is joined, whoever it is.
Nirmit.
Huh?
Nirmit.
Nirmit? Sorry, go ahead. Maybe before I stop recording at this time, and then we can just. So we are ending the call today, and we'll do it next week. And then after I stop recording, you want to talk personally, that's fine. Jamie?
Yeah.
Can you stop recording? I'm not able to stop.
Yeah.